we can see here the medical biopolymers. Medical biopolymers, packing materials, these are the applications of that particular glycopolymer. The main aim of this study is the formation of binding sugar conjugate and the use of glucan and acetyl as a target carbohydrate molecule. And after getting that target compound, the binding of BICON and glucan conjugate occur with avidine or streptavidine. And to check the binding affinity of BICON conjugate with WGA, we use the fluorometric assay by means of specific excitation of tryptophan at the wavelength of 295 nanometer. And this is the main target material of my research. Here we can see the glucan, this later the peptide bond with BICON. And this is the main synthetic group of my research. The first step was acetylation. Here we can see that acetylation occurs in this reaction condition for 4 hours at room temperature. And I got the compound number 2 with 75% of E. The next step was glycosylation. I used such reaction condition to got the compound number 3 with a crude of 98%. And then the glycosylation occurred with such reaction condition and got the compound number 4 with 73% of E. And then the displacement reaction occurred. Here we can see that the chlorine displaced by the azyl, and then the deacetylation occurred. The OH compound, the OH is replaced by OH. And then the reduction reaction where the azyl is reduced to amide. You see here the reduction, and it was the E was 77%. And this is the main BICON coupling reaction. Here we can see that the BICON is conjugated here and the peptide bond formation occur using such reaction condition, the DMPM and DML, to got the compound number 6. But it is in crude form. It was not pure, so I thought to do the reacetylation to make it pure, because the solubility was the main problem and the purification was also the main problem. So again the reacetylation occurred, and then I got my final compound number 8 in quantitative yield. Then some troubleshoot occurred during the reaction, so these are the troubleshoot. So the final was DMPMM, it was good, the coupling reagent. And these are the physical and chemical properties of my compound number 7 and 8. Here is the color, the melting point and optical rotation and their solubility. And on the basis of these physical and chemical properties, we can say that the compound number 7 and 8, these are noble compounds and these are pure. Then the avidine-BICON complex reaction and purification occurred. Here we can see how the glucan, my main material, attached with avidine, which is the tetrameric avidine. Then some glucan residues formed as a byproduction. Then this glucan is purified by using size exclusion chromatography. This is dialysis process to purification. Then freeze drying of sample, then absorbance of concentration, got to know around 0.257 micromolar. Then extinction coefficient of avidine. These are the affinity interaction checked by the fluorospectrophotometry using glucan and WGA first. So the Ka association value was this one. In between we can see it is 1.01 into 10 to the power 4. It is normally above. And this is the affinity between the monomer 8 with the compound which I synthesized with WGA. And you can see it is 9.62, almost same like glucan. But if we talk about the avidine and BICON glucan conjugate with WGA, here we can see a very huge difference between the interaction. The Ka value is very huge, 5.56 into 10 to the power 7, only because of the avidine, because it is tetrameric and very large in size. So these are the absorbance concentration analysis by UV probe. In this I just calculated all my results. These are also here we can see the difference between the Ka, the association constant. The monomer 8 with avidine with WGA, it was 5.56 into 10 to the power 7. It is the highest. This is my conclusion that I already talked about. This is my future plan. My future plan is using BioCode to check the interaction of glucan WGA biotin with avidine and act as an analyte and ligand on the surface. So it is a kind of principle to use in BioCode, and this is a complete structure of my final product. The avidine, BICON, glucan and WG. Thank you so much for your time. Any questions? Yeah, sir, actually to control the sense, as we know that everything is a tetrameric form. So first we need to denature it at around 95 degrees C, because as a tetrameric form, if we will attach, so maybe some residual formation occur, or maybe the attachment will not be completely sufficient. So first denature and then interaction will occur, so that we can control the size. It's an editing, 4 compound, all the 4 things.
Yeah, I think this is one of the wonderful examples because Amrita is just one of you who choose to do the doctoral course from abroad, and now she is able to make such wonderful presentation in one month. Next year she is going to have a doctorate degree. So I think one of the wonderful examples for all of you that how you can initiate research when you are in undergraduate or postgraduate course, and then further go for advanced course when to find some opportunities. So I appreciate Amrita for such a wonderful. I also I think should share with you that in last 2 years Amrita has won many several awards. How many? 3? 3 awards. And in just 2 years. And the last award was in Rome.
No, it was in Turkey.
In Turkey, she got the best paper award in Turkey for international conference. So I think she is doing a very wonderful job. So please get that motivation that how you should start your career, right? Thank you.
Now it's the time for the industrial panel session. I would invite Professor Biyani sir to take over the session.
You must be tired, right? No, we are not tired, okay? Only if you think you will tire, okay? Because this is the time when you have some extra knowledge. So always have a feeling that we can never tire. So, should you need to recharge? So how would stand up? Just have something so you can recharge. Yeah, it is very important, okay? Fine? Okay, sit again. Sit down. So, now we are the real session actually. For what purpose we have designed, because from morning you are having 3 different sessions. First biology, then physics and chemistry. So you got some idea, and now you are talking about how the research can be implemented in the industry area. Because our only target to make some good research that can be used by industry and then to our society. So we have invited 2 persons from 2 industries, one from Japan and one from India. From Japan, Dr. Biyani is with us. Basically, she is a medical physician. She has done a medical course in India, and then she started to do research in medical field, and now she is making some new biodevices for healthcare purpose. So Dr. Madhu is with us, and she will be talking about disposable electrode printed chip for electrochemical detection of heavy metal and environmental analysis. Because recently we got the problem in Maggie, the heavy metals lead. So if we have such novel devices in our home, it's very easy for us to get screen our food products. So I think one of the wonderful work.
And then come on the cancers have found that these metals are generally the very these metals are the toxic metal, and they can be non or probable carcinogens and can damage the multiple organs. And the most susceptible victims are the children and the pregnant women. If the pregnant woman exposed the high level of these metals may cause the miscarriage. And the children, these metals can reduce the growth and development of their brain. So it is very critical to control and determine the concentration of these heavy metals in our food and drinking water. Here is the evidence. We all know that the Bangladesh is suffered with the crisis of the arsenic toxicity. Their soil is contaminated. Their soil and the water is contaminated with the arsenic, and that is the higher than the permissible level. And so now there are the many reports have shown that these people are exposing there is a high level of the arsenic and showing the clinical pathological conditions that are the cardiovascular diseases, peripheral vascular diseases, and there is skin lesions, and they are also cause the cancer. So these are the evidence. We have to be taken the lesson, and we should control the quantity of these heavy metals in our foods and the drinking sources. There are the detection issues for the heavy metal toxicity. There are the two main reasons. One, that these heavy metals are very colorless and odorless. We cannot identify, and there is a lot of the chances we have unwittingly exposed such high level of these heavy metals. Second is although there are several standard analytical technology to detect these heavy metals, but the main problem that this technology is very expensive, time-consuming, and need of highly skilled operators and well-equipped labs. Therefore, we need such a device that have affordable, we can purchase at the low cost, that is accessible, we can check these heavy metals at the home, and it should be portable for the field applications, and it should be sensitive, that can detect the trace amount of these heavy metals. So before talking about the electrochemical devices, I should want to give you a brief knowledge about the electrochemistry. What is the electrochemistry? It's the field where it studies about the chemical reactions that takes place between the interface of the electron and the ion solution. Here, that involves the electron transfer from a species or to the species by applications of the external voltage. So generally, the electrochemistry has numerous applications in the analytical chemistry, and it is the emergence of the several electrochemical biosensors and the sensors. Here is the electrochemical biosensor and sensor. The principle of these biosensors, generally these electrochemical sensors compose of the two parts. One is the receptor and second is the transmitter. Receptor generally recognize the target. It is specific to the target, and it recognize the target very sensitively and selectively. And second is the transmitter that transduce the recognition event in a measurable physical signal. And there is the three cases. Generally the electron transfer from the target, and another is second intermediate setting. There is the two receptors, and in the second receptor is tagged with the electroactive tag, and the electron transformation around the working electrode, and these signals identified by these electrochemical biosensor, we can detect the target molecule very high specificity and selectivity. When we are talking about the electrochemical biosensor, the one popular name comes into our mind, that is the glucose sensor. I think you already know the glucose sensor. This is the most popular electrochemical biosensor that is have the high impact monitoring for the diabetes management at the home. The glucose sensor generally implies the use of the enzyme that is called the glucose oxidase. This glucose oxidase generally catalyzes the glucose into the hydrogen peroxide and the de-glucose the lactone, and the hydrogen peroxide is electrochemically detected and this can be the concentration of the hydrogen peroxide is proportionally to the concentration of the glucose. This is the mechanism this glucose sensor works. Here I am happy to introduce the Japanese company where I am working. This is bio-device technology. This technology is born from the Japan Advanced Institute of Science and Technology, and this company was established in 2003, and the founder of this company is Professor Iki Tamiya. He is a well-known scientist and he is the professor at the Osaka University. And the main aim of this company is to commercialize the products of these universities into the market. This company is developed the biosensor. It has an expertise in the high sensitive chromatographic chip construction, and it also constructs the DAP chip series for the giving the platform for the electrochemical biosensor. Now here we will talk about the disposable electrode printed chip, or direct name is the DAP chip. This chip is very small in size and it has the electronic properties, and it has 3 electrodes: the working electrode, reference electrode and the counter electrode. And this is very the material generally used for the working electrode is gold, carbon, platinum or silver. According to the analyze we want to analyze. The another product is the potential state, generally used for the giving the external voltage to measure the electrochemical measurements. It is very lightweight. Generally, the conventional potential state very large in size, and it is very small in size, just palm size, and very easy to use. And it has the software. Using this software, we can measure the various electrochemical modes such as LSP, CV, CA, DCB, and SWP. In this slide, I'm sure there is the fabrication of the DAP chip. The DAP chip is generally based on the technology, screen printing technology. This technology already exists traditionally in the art, textile, and advertisement field, and this technology researchers use for creating the electrode device. And generally, these device use the carbon, silver, gold, and platinum inks for the construction of the electrode. And I will not go into the deep of the fabrication of the DAP chip. And interestingly, these chips also can be prepared on the ski, on the stress ball, and the underwater garments, and used for the high alert signals. And so advancing of these DAP chips is going on. Here is the various type of the DAP chip series. Here is the round DAP chip is differentiated according to their working electrodes shape, their materials, and you can see here is the round working electrode chips, the square working electrode chips, or according to the PCR tube, it's modified to the PCR tube shape, and the working material used for the working electrode is the gold, platinum, and carbon. Proportional to the concentration of the metal. And interestingly, this method is described in the 1920 by James Clay, and he won the Nobel Prize for the chemistry in 1959 for developing this method. Here we optimize the condition for the analytical detection of these heavy metals for the cadmium, lead and arsenic. For the cadmium and arsenic, we found that the gold working electrode is suitable, while the lead, the carbon working electrode show the characteristic for the lead. So here we investigated the analytical performance of the gold depth sheet for the detections of the cadmium. Here we got the responses for the different, DCT responses for the different concentration of the cadmium, and we found the linear calibration curve between the concentration of the cadmium and the peak current in a several manner, and the range we can detect here from 5 to 160 dB, and we according to the standard deviation of the blank sample, we determine the lower limit of the detection of the cadmium is around 1 dB. Now we also perform the we also investigate the analytical performance of the carbon depth sheet for the detection of the lead. Here we also tested the different concentration of the lead and got the DCV responses, and we also got the favorable wide linear calibration curve for the concentration of cadmium and the current we obtained. And the lower limit of cadmium lead detection we found it is less than 1 ppb. And we also tested the carbon depth sheet for the simultaneous detection of the cadmium and the lead. Here we can accurately detect out the cadmium and Cb in the standard solution. And these results show that the depth sheet has the efficient for the detections of the heavy metals in the standard solution. Here we use, after optimizing the condition for the BICON, we use the real sample. We selected here the Indian rice sample 1 and 2, and for the positive control we use the Chinese rice that is already non-organic with the 300 ppb cadmium. However, here is the question: why we tested the rice here? Because the rice is the most stable food, and around 3 billion people taking it every day, and it is a food crop that is mostly polluted because it requires water, irrigation of water, which may be polluted by the raw seaweed, effluent and untreated industrial water. We also tested here the Indian noodles using the depth sheet. And here is the water sample we have taken from the company lab and tested for using the depth sheet. This is the general permissible limit that is approved by the FDA, EPA, USP and WHO. The arsenic the permissible limit is 1.5 ppm, and cadmium in the solid food 2.5 ppm, and lead 1 ppm, and mercury 1.5 ppm. Here is the before using the depth sheet for the measurement of these heavy metals. Here is the preparation we have to do. We have to take the 2 gram. We have taken the 2 gram of rice powder and heat it for the overnight in dilution for the acidic dilution. Here and after the dilution, filter out with the filter paper, and column and again purified with the column and diluted in the 0.1 molar HCl. This is the protocol, but we will not go in the deep. Only the important point is that the sample solution we prepare, the pH of the sample should not be less than 4 or not more than 6. Here is the demonstration, real picture of the device of the depth sheet potential stack method, and it is very small setup. There is no need of well-equipped lab, it is very easy to use. Here is a small video where we due to a shortage of time, I of the cadmium in Indian rice sample found is around 300 ppb. That is the lowest in the management stage. And we also use Chinese rice that is thinking with the 300 ppb cadmium, and it shows that the reactive method is accurately calculate the amount of the heavy metals in the food stuff. Now this is the result of the detection of the cadmium in the Indian rice sample 2, and here we got the similar result. The quantity of the Indian rice sample 2 is the concentration around the amount of found around 300 ppb. And we also tested the lag in the Indian rice sample 1, and here we found the quantity of the lag in the Indian rice 1 around 60 ppb. This is also below the lower limit, permissibility limit of the lag in the solid food. Here this is the result of the lag detection in the Indian mineral samples, and according to this lab chip analysis, we found the Indian mineral contains 180 ppb, that is also below the permissible level, and this result shows that the lab chip is very efficient to calculate the amount of these heavy metals. Here we detected the arsenic in the sea water and taken from the Japan, and we found the quantity of the arsenic in the tap water around 10 ppb, and that is also in the permissible limit. Now I conclude my presentation here. The lab chip is related on the good for the electrochemical measurement, and it is very sensitive to detection of the lag and the cadmium in the rice and the mineral sample. It is also found sensitive for the detection of the arsenic in the water sample, and we can believe that these simple and clean preparation of these methods can have the scope towards the mass production of these lab chips for the sensor development for detection of the heavy metal analysis. Now, we also believe that lab chips hold the promise for the wide applications in the environment, biological and food analysis. Now, I am my presentation to provide you and healthy life. Thank you very much for your kind attention.
Thank you very much, Dr. Madhu. I think it is one of the wonderful technology that we can use in our daily life. So one quick question, if you have anyone? No? Then if no, I think Dr. Madhu is also planning to introduce this depth technology in Jaipur, because he already installed one company here. So many of you can be part of the research, use the technology, and for many other applications can be done in future. So thank you again, Dr. Madhu, for making this nice presentation. So the next, another industry from India, in fact from Jaipur city, Mr. Rakesh Saini, who is the scientist and in charge of National Test House. And I would request Dr. Rakesh Saini if he can introduce his company and please elaborate how the students can get benefited from your company and to get.
It is our building, our lab is it is very near to your college, around 3 to 4 kilometers at road number 9F1. Basically, our headquarters is at National Test House, Calcutta. National Test House is under Department of Consumer Affairs, Ministry of Consumer Affairs, Food and Public Distribution. You might be known Jaipur Grahak. So our ministry main motto is to give awareness among the consumers about the food products, about the general services available so that the awareness should be there. We should choose a good product, good service. So it was established in 1912. In 2012, our institution has completed 100 years. So it is a very old institution which was established by British for testing their products, which they have used to make Indian industry. We are having 6 branches. Apart from Canada, we are having 1 branch at Jaipur, and 1 branch at Hyderabad, 1 branch at Guwahati, and 1 branch at Mumbai, and one at Chennai. All labs are well equipped for different engineering goods, testing of engineering goods, chemicals, packaging in water, food. There are plenty of divisions we are having. In response of Government of India intention setting up Northwest Region, National Test Authority the state of Rajasthan, NTH has made an elaborate assessment of the feasibility, suitability and commercial viability of the proposal. Basically in 1993, this center was established for testing of cement products, because at that time many cement industry was there, many cement plants were there, so they are not having the testing facility. To facilitate, to provide them the testing facility in cement testing, our lab was established in BICON area, which building was provided by state government for testing of cement. But as the time moved, we have developed different divisions also. Now we are having 4 divisions. Civil engineering division, we are testing building material. Second is chemical division, we are testing cement as well as metals, as well as packaging in water for pesticide residue for heavy metals. And for electrical lab, we are having facilities for testing of industrial electrical cables. For mechanical, we can test steel, and for plastic, we can test SDPF PVC pipes. The new building at Vishkram Industrial Area was constructed in 2006, and this is a very good building. We are having presently 1 basement and 1 ground floor, and soon first floor is under construction in where we are going to establish solar panel testing. So there are general laboratory testing of cement, water line, coal, preservatives, plastic products. In metal lab we can test. We are having OES, optical emission spectrophotometer, by which you can test in a less than 1 minute you can get the composition of any metal. Ore, minerals, galvanizing, coating thicknesses. Water laboratory, we are having complete testing facilities for packaging in water, including pesticide residue for heavy metals and all physical and other chemical parameters. We are having microbiological lab for testing of water as well as food items. All our labs are enable accreditation. I don't know whether you person are knowing or not. Enable accreditation is international recognition of a lab, that our test results will be at par with the international labs. That is ISO IEC 17025/2005. So every lab which is going to test a product, it should be enable accredited. Otherwise, our test results have some doubt. So to remove that doubt, your lab should be enable accredited, so that your test results will be at par with the international. This is our spectrophotometer for pesticide residue analysis, water and food and vegetable. So this might be testing for you. Any student who want to have research on and want to use this equipment can come to our lab. This is double layers. Although it is an old technology, we have got one ICP which can test heavy metals at a single glance. This is ICP by Lehman. This is for testing of heavy metals in water and food. And this is, I was talking about the chemical, how we can test the chemical composition. Because in classical methods, it takes around 2 to 3 days to check the chemical composition of stainless steel. Whereas in this machine, we can check in less than 1 minute. You can get the complete 10 or 12 elements which are available in the stainless steel. So it is a wonderful thing. You people can visit, and if you have some research on metal, you can utilize the services of our instrument. This is FTIR. This is for polymer identification. This is mercury analyzer in water and food. This is UV visible spectrophotometer. Basically, my background is not chemical, so you people might be more aware of these instruments and just explore how can you utilize our services. This is the vacuum evaporator for sample preparation for vaccine recipe. This is biosafety cabinet for our microbiological lab. It is a very good lab, and soon we are also going to develop a new microbiological lab of an international standard. This is laminar flow also used for microbiological testing. This is for instrument you need ultra pure water. So this instrument is producing ultra pure water. This is civil lab. It is humidity chamber which is used in testing of cement. After making cubes, you have to put cement cubes in the 90% humidity and 27-degree temperature. So these humidifiers used for humidity chambers are used for cement testing. This is vibration machine to making cement cubes. You might have heard OPC 33, OPC 43. These are all Portland cement, and now in latest we are having PPC, Portland pozzolana cement, in which we are using fly ash, which is generated from the thermal plant. So it is a very good use of fly ash. Otherwise, it is very difficult to dispose of fly ash which is coming out of the thermal plant. It is load framing unit for testing of block boards. There is a tile abrasion machine for testing the abrasion resistance of the tile which we are lay on the floor. This is autoclave machine to use the test counter test of cement and glazing test for tile. This is compression testing machine of 50 ton to check the compressive strength of cube or any material. This is of 2000 kilonewtons, a bigger machine. It is a fully computerized servo control machine. It is a machine from Korea, Bata. It is of 3000 kilonewtons. It is curing chambers for curing of cement tubes. In mechanical lab, we can test steel bars, generally used in the buildings, HSE bar. In Hindi, we can call Saria. That is a high strength deformed steel bar. They are TMT bars, barber bars. This is impact testing machine for testing of Charpy and isotope impact test. That is the toughness of metal. This is our 1000 kilonewton UTM testing machine. In this machine, you can check 40 mm diameter of steel directly. This is hardness testing machine, Rockwell hardness testing machine for checking the hardness of metals. This is also an imported machine of universal hardness testing from Northern Germany. In this machine, we can test the hardness of different hardnesses like Vickers hardness, Brinell hardness, Rockwell hardness. In a single machine, we can check all type of hardness. This is universal hardness testing. This is the Vickers hardness testing machine. It is Indian made, and this reversal test of UPVC pipe. This is a smooth and porosity tester for paper. This is the humidifier to keep the humidity in the testing area. In some tests, you have to keep the humidity 65% as well as temperature 27 degrees centigrade. So just to keep the humidity in the testing area of 65%, this is humidifier. This is automatic control the humidity of a testing area. It is our revenue from we have started Jaipur lab in 1993. From some lakhs of rupees we have reached to above 1 crore rupees in 13-14. Thank you. So I will request you all our facilities. You can utilize for your PhD work, so your research work. Thank you very much.
Thank you, Dr. Sanidhya. I think he has proposed a wonderful opportunity for all of you, because such a facilities we have very near to your campus, and thank you very much for your offer. I think it's very good for our students. If you want to do some research or if you want to do some training, if we can get benefited, because getting a facility of instrument is one of the major challenges in this city, I think. And if such company are making such offer, I think it's wonderful. Thank you very much, and we look forward to this. So with this, let's thank again our both the speaker from industries, and I think we are very soon we are planning to work with industries and to secure your future career just after graduation. So thank you again, Dr. Madhu and Mr. Singh. Thank you very much.
Mike.
Yes, there is always a selection procedure, but the main thing that how you initiate for your research project. So I always encourage the mind to please first involve some small research project, get interest, make your background, and then we can further advance your research.
And regarding this lab in particular, I wanted to ask, do we have supervisors?
The last which sir has mentioned just about this, I wanted to ask, do we have supervisors also there to guide us to work on the instruments, or the researchers by themselves?
So do we have some technical persons there or supervisors?
Yes, we are having qualified persons, chemical, they have PhD.
To guide the research?
Yes, naturally, no problem. Basically, I don't know how I have to bring one chemical person with me because I have no chemical background. So he might have told you much better. But definitely you can come along your lecture professors for a visit for one day, and you just see our lab. If you want to see that what instrument you can use in your research, definitely for more time you can come and get your sample tested or do your research up at a convenient of no problem.
That's all. So I now close this session. Thank you very much again.
Thank you, sir. Wonderful session we had, Saini sir and Madhu Biyani and Professor Manish Biyani sir, which was very memorable and information with us. And once again, thank you so much. Now it's time to give acknowledgement to our winners of poster and oral presentation.
So for the poster presentation, the first prize goes to Ms. Pushpita Aswal from IIS University.
Please give her a round of applause.
And the second prize goes to Chihiro Nakara. And
I will request to Professor Sanjay Biyani sir, Manish Biyani sir on the stage for giving acknowledgement to our winners.
please have a big round of applause for the winners.
Big round for Chihiro. Thank you, sir.
In oral presentation, the first prize goes to Ms. Ankita Kushwaha from Biyani Girls College.
Yes, big round for Ankita Kushwaha.
And the second prize goes to Rimo Hayama from Saitama University.